Now, let's find what the earthquake light events that have happened have been. So let's say here, let's go ahead and just plot. We can go ahead and plot as a function. Well, I'll tell you what. Let's first of all, let's get the locations of all these things. That'll be kind of interesting. So let's say that, and then we want to say all, comma, position. That should give us a bunch of geopositions. So now let's go ahead and say for those geopositions, let's say we want to make a geolist plot of all of those. Oops, that's not the right thing. I want to say the values of those, values that we see in there in line 3. And let's make a geolist plot. Okay, that's not, well, it's kind of interesting because those things form kind of a pattern there. But let's take a look. Let's look at this with respect to with respect to the local topography. So let's say geo background arrow relief map. See what that looks like. Okay, interesting. It's kind of interesting that these things form a pattern like that. Let's figure out what the sequence of tests was as a function of that, as a function of location. So what we want to do there, that was on line 3. Let's actually call that locations is what's on line 3. And actually, I'll tell you what, let's say values of line 3. That's now locations. So now we can say, let's do the following. Let's say we want to label each of those locations. So we'll say labeled, and it's locations. And then we want to say geo list plot of that with geo background as this. Okay, all right, that's interesting. So that's today's thing. I guess 6 would be the magnitude 6.3 piece, and 7 would be the subsequent 8 minutes later magnitude 4.1 piece. But these are the this is the sequence of tests done in previous years. We can probably mark what year it was. Let's go ahead and see if we can mark the year, or for that matter, we can mark the magnitude of each of these tests. But I think they've just been of slightly increasing magnitude. So let's see what it looks like there. Let's see what the actual geo image looks like for those locations. So let's say geo image of, actually, I'll tell you what, I could just make background here be satellite. Oops, okay, that doesn't use a high enough zoom level. I think I might have to use a different geo server. That's rather uninspiring there, but let's use GeoImage, which is a new function here. Let's just say GeoImage of locations, and that should give us a higher resolution image that just shows the region around those locations. Okay, let's pick today's locations. Let's pick location. And let's go ahead and look at the GeoImage associated with those locations. Wow. That's a bunch of trees. Let's take a look here. I think that's just a bunch of trees. Now let's see whether we've got any higher resolution data here. Let's go ahead and take GeoImage, and let's just take the second to last location, which was the big, just to see whether we've got any higher resolution data here. Let's say geo range, arrow, let's say 200 feet. So that's going to show us the 200 feet around. Okay, not extremely helpful. Looks like it's a somewhat obliquely taken satellite picture with a bunch of trees. So that location is probably accessed through some kind of tunnel. So let's just take a look at what the local topography is. So let's look in this area here for the locations. Let's go ahead and extract the geo elevation data for the region around those locations. Let's do this. Okay, now let's make a list plot 3D just to get a sense of how the topography looks around there. Interesting. Okay. Okay. So it's kind of mountainous. Look at that, 7,000 feet altitude. There's probably some kind of river-like thing that flows through here. Let's look at let's go ahead and look at, let's see, I really want to get the locations shown on that map. That's going to be a little tricky here. Let me think how to do this. I want to get these geolocations. Let's see. So those are the geolocations, and now I want to map them onto this region that corresponds to geoelevation data, because this geoelevation data is just a, let me just take a look at something. Maybe there's a way of asking geoelevation data to give us the thing in its, okay, so this is the types of elevation. Okay. This is a quantity array versus a geoposition array. Okay. And I want to go ahead. Yeah, what I'm trying to do is to map those geopositions into the georegion that, let's see, if I say geo-bounding box of locations, I should get the bounding box for those locations. Now, maybe it's geo-bounds I want. Now what I want to do is to say geo-bounds of locations. Okay, so now what I want to do is I want to say relative to those, what are the positions of the actual points here. Let me think how to do that. Good way to do that. Relative to that bounding region. Let's go look at the documentation for geo-bounding box, see whether that helps us. Always good to see the see alsos. Yeah, so what I want to do is I want to find in that bounding box well, one way to do this is just to take like that location there and just say where is it relative to, yeah, I don't know how instructive this is going to be because we can already see, okay, so that's the topography there, and now let's take a look back up here at where the actual locations of the tests were relative to that topography. Okay, so here are the locations of the tests, and let's see, do we see that topography? So that's the branch there, so in fact it's rotated around like this. It's upside down. Come on, rotate around. I think that's right. Oh, I flipped it around. I have to flip that over, but what we can see there is those locations are spread out across here. So it's not, so whatever that riverbed is or whatever it is down there, we can probably try and see what that is. I don't think it's relevant to this. Let's just see relative to these locations, let's just take a look at let's see, at where the nearest road-like structures actually are. So okay, so if I just do this, we don't see very much. So let's go ahead out a bit and let's go to a geo range of, let's say, 20 miles. And let's see whether we can see where there are things like roads coming in. Okay, that's interesting. I wonder what that structure is there. Okay, that looks more like a river than roads, but maybe it's roads. And I wonder what that boundary is there. That must be some kind of administrative division boundary. So let's actually find out for these locations. Let's say geo-identify. Actually, why don't we do this? Geo-nearest for each of the locations. What is the nearest city? Let's just do it for the second to last location. Okay, just curious. Okay, that's that. Let's just find the 5 nearest cities, and let's go ahead and just see where those actually are. So let's say geolist plot. Okay, so those claim to be cities that are near this location. So the location is here, the cities are over here. Let's just take a look for that city there, whatever it is. Let's see what we know about that city. Let's see what it thinks the population of that city is if we have that data. Okay, interesting. Let's take a little look at what that city looks like in a geo image. Not extremely. Let's go ahead and look a little bit closer here at the city center. If we can find that, let's say 1 mile. See whether we can even see. Oh yeah, there's a little city there. Okay. Interesting. We wonder where these, so are those roads? They may be roads. They certainly look like roads. Okay, so let's go in and let's look at this a little bit more closely. Let's go ahead and look at 0.1 miles. Okay. Yeah, they're roads, maybe dirt roads. I wonder what those other things in that city are. I wonder whether we can get dynamic geoimage to work here. Okay, that's showing just probably OpenStreetMap data of the road configuration around there. Kind of interesting. What are those? Those must be train lines. I think they're train lines. Now why? Okay. Is that a different city? PyCam? Let's see what PyCam is. Okay, oh, it's an administrative division. All right. Let's see in which that city occurs. Okay, it's certainly curious that there are what appear to be train lines coming to this thing. And there's also a train line, it appears, unless that isn't a train line, something marked in this picture going up there. So that's rather curious. So let's see. This is one of these cases where it'd be better, where I should set this up to work dynamically, but let's go ahead and look here. Yeah, well, at least in these images here, the things basically just peter out there. Okay, so let's take a look. Which one is this? This is, let's go ahead and just plot this and wherever this is together with locations, and let's go ahead and label that as let's label it with the actual name of the city, and then let's put those locations there, and let's go ahead and say geolist plot. Okay, so that gives us a sense of scale there. And it also shows us that whatever's happening here, see, I think there's a way to put a visible scale on this thing. Let's find that out. Let me see. I think we can put an explicit scale on here. That's that. How do we include a scale? Well, not immediately sure. But at least we could, let's do this. This is definitely one way to effectively include a scale. Let's put a geodisk around here with a radius of, let's say, 10 miles. Not sure if that's going to work in geolist plot. Oh yes, it is. There we go. Okay, so that's showing that this site is about 10 miles away from the center of that town. Now I'm curious when it comes to tunnels and things. Let's look at things like, I don't know, what's a famous tunnel? The Mont Blanc Road Tunnel. Let's take a look at what we know about that. Okay, so let's say, does it have a length? Yes, it does. Okay, 7.2 miles. Okay, so that's kind of a long tunnel. And I'm curious what it looks like. I'm also curious what these structures that are marked up here are. And I'm curious, when you look at kind of the entrance to a tunnel, what does it actually look like? So let's look, for example, at the Mont Blanc Road Tunnel. Let's say geoimage of the Mont Blanc Road Tunnel. Let's see whether we can even see what's going on with something as sort of obvious as that. Bluff. That is hard to tell what's happening. Let's see what happens if we look at the geo-elevation data around there. And see whether we can see anything. We may just see a giant Mont Blanc here. So let's say list plot 3D. Let's use make contour lines there. Okay, let's see what this looks like. Oops, what happened here? What did I do wrong? Oh, that's a single location. That's why that isn't working. Okay, let's make a. I wonder where it's probably not marking separately the input and out in the entrance and the exit from the tunnel. Let's go ahead and do this. So that's now making a 10-mile disc around the presumably center of the tunnel. Let's see what that looks like. Wow, okay. That is pretty mountainous. Well, it's interesting to compare that actually with what we're seeing in North Korea, because this is okay, so that's a 10-mile region around Mont Blanc. just out of curiosity, let's go ahead and make a 10-mile region around the big explosion of yesterday. Still taking a while. Okay, just curious what the topography looks like. Okay, so it's also quite well, there's a difference there because that's between 2,000 and 6,000 feet. In the Alps, it's somewhat higher, but qualitatively, that terrain. Okay, so that's what the terrain looks like around there. Centered on that location. I'm curious. I mean, I assume that's a riverbed, but I don't know. Okay, so we're pretty unsuccessful here at seeing. Let's actually now. I'm curious about something else. If you look at like previous test sites, like in the US, what do they look like? Now, obviously, they weren't being hidden, at least not for a long time. Let's take a look at what we've got there. So we should have a bunch of data on nuclear explosions. Let's see what we have here. Actually, this isn't the right way to do it. Oh yeah, okay. Let's actually go ahead and I've got a better way to do it. Let's just say nuclear explosions. Okay, so let's get an entity list of all of those, all the ones that have happened in history. Okay, so there's a big long list. Actually, I'm curious how many there are. 2,430, okay. Oh, I wonder where they were. So let's say that was line 36. Let's see if we can make a geolist plot of all nuclear tests and nuclear explosions of any kind in history. Let's see where they were. Have to download all the locations and things. And then I'm curious to actually look at geoimages around some of these. Okay. Well, definitely a Soviet or Russian theme. Europe has not had any of these. Those are the US nuclear tests, I think, in the South Pacific. Let's take a look. Let's pick a few random nuclear explosions. So let's say we pick 5 random nuclear explosions. Okay, so it looks like there's a couple here that are Chinese. Let's look at that Chinese one. Let's see where it was. Let's look at a geo image around that one with a geo range of 5 miles. Just see roughly what it looks like. Okay, another fairly mountainous area with nothing very visible. Let's go and zoom in a little bit more on this. Let's look at a 1 mile radius. Okay, now I'm curious to look at like even more zoomed in. Let's see, let's say 0.1 miles. Basically nothing to see, except maybe that, whatever that is. Maybe that's a natural object, maybe it's not. It's always hard to know whether things are, when it's a natural object, when it isn't. Actually, the one thing which is kind of interesting for these tests here, if we look at the actual times of these tests, these are in GMT. So let's go ahead and look. Those are on line 2. We actually had the list of all those things. There we go. Let's go ahead and look at line 2. Let's look at all those, and let's look at, well, it's called period. I don't know why it's called period here, but anyway, let's look at this. So those are times, and what we notice is that these recent ones are precisely, actually, if we do a time zone conversion, let's convert these to a time zone. Let's see, what is I wonder what North Korean time. I think it's a time zone, local time. Great. Okay, 4:02. But let's, oh yeah, it's GMT plus 5. So GMT plus 8.5. In other words, it's a half-hour time zone. So those explosions took place at within a second of the top of the hour. These ones here from earlier were not as precisely timed, and I guess this occurred, whatever this smaller event was, occurred 8 minutes 32 seconds, 8 minutes 30 seconds after the initial thing. But it's sort of interesting that we can tell that these are man-made events by the fact that they align so precisely with sort of top of the hour, and that's sort of a signature of it not being a natural process. Well, let's see. I am curious what else we can easily find. Oh yeah, I was going to look at what some of these places look like. Okay, so let's go ahead and look at the 1 mile radius around these randomly chosen. Okay, so I had them randomly chosen on line 39. I had a bunch of randomly chosen nuclear tests, and let me go ahead and let's just label them just so we know what we're looking at. I'm just going to make images of the 1 mile radius around those tests. Okay, these are pretty uninspiring. That I would suspect is an American test. Well, that one, there's clearly a bunch of roads and things, and I'm kind of guessing that those dips there are from collapse associated with tests. I wonder whether one can actually see that in the geo-elevation data. Let's take a look. Okay, that's a funky case where there are 3 satellite images all meeting, which is really odd. This is another really desolate spot. And this one, again, there's some definite roads and things visible there. I'm just curious about this one, whatever toggle flax test is. Let's find out. Let's go ahead and look, just see what we know about this toggle flax test. Okay, US 1972 Nevada test site, etc., etc., etc. Underground shaft. Actually, I'm just purely curious whether we can actually see in a 1 mile radius there. If we can see, if we look at the geo-elevation data, that won't work. I have to just tell it to look at geo-elevation data for, let's say, a disk around that location. And then let me go ahead and plot that. And I'll add in the contour lines. Oh, wow. That's pretty funky. So we can see there, look at that. We can see those dips where the actual nuclear explosions occurred and where the ground collapsed above them. I wonder how deep those dips are. And I wonder whether those explosions must have been, yeah, I mean, I wonder, those explosions must have been quite close to the surface, but I wonder, let's find out how deep those dips are. Oh, we can actually see here. Those dips are basically a few hundred feet down. Interesting. And I think, well, let's take a look at whether we can actually see where the nearby, I wonder if this works, geo-nearest, and then we can just say nuclear explosion. Let's see if this works. Oh dear. Now let's see, let's say the position of that thing. Oh, well, that doesn't work. Okay. Then what I want to do is if I say entity, let's take a look at what we know about this. Well, I'm not sure this is too exciting. We could probably go and look at a few of the other. Could probably do more of an analysis of this, but let's not bother. What we were going to look at, what I was curious about is, can you see in those original pictures, wherever they were, up here? So that was a nearby town, but let's go ahead. Yeah. Hard to know anything about what is going on here and what those fields are like and so on. I mean, I'm curious, I guess. Let's go ahead and, I mean, there's clearly some larger structures here, and that is presumably train lines, which is kind of odd to find in this area, but whatever. Let's see. I think what we want to do here, yeah. So what my goal before giving up here was to see whether we could tell anything about kind of what was going on in this area. So this was our original picture that showed these locations, showed the area around here. Now it's not clear how. So how would we identify something like the entrance to a tunnel? Well, the thing I could imagine doing is some lovely machine learning exercise where we look at a bunch of other things like that and then go do a search in an image like this. But this is a hard image. See, yeah, this is a tough image to search in. And let's take a look here. If we zoom out a bit more, let us go ahead and say geo range of, let's say, 10 miles. Now, at 10 miles, we would get as far. Oh, great, there's a bunch of clouds. Oh well. And we can actually, we can ask for higher resolution if we want to. Let's see, if we say geo zoom level, I don't really know my geo zoom levels. If we say geo zoom level 12, what happens? Maybe it takes a really, really long time because that's maybe very high resolution. Okay. Oh. The and let's see. Okay. Let's take a look. Let's see. Okay, well, let's find the position of the very last, in this image, let's find the, let's center this on the very last event. There's clearly, now I really need to be able to show in this image the position, that last position, which will be at the center of that image. So let me just remind myself how to do that. Let's see. I think I can just go ahead and put that at a particular scaled position, but I mean, I'm sure it is basically at that center there. I mean, yeah, it's hard to know what's happening here, but let's see. Let's take a look at the two most recent locations here. This is a very nice, let's see whether we can get an even higher zoom level. It'll take a lot longer, I suspect, to load, but see whether we can get a higher zoom level for that area, so we can zoom in and maybe we can chop it into little pieces and we can try and find what these different oh, that's ugly. Okay, so at a higher zoom level, that purports to be the exact same place, but at a higher zoom level we're seeing different satellite imagery. What is that? What on earth is that? It's hard to see here. You know what? I wonder what will happen if we just take that image and we do some image processing on it. So let's take that image and let's say image adjust to that image. Nothing much, well, it became nothing much happened. I wonder what that is. That's really an odd thing there. I wonder what that is as well. Let's see what we can do with a little bit of image adjustment and maybe also superimposing some elevation data over this. I mean, there's clearly all kinds of stuff going on, and if I was a real satellite images analyst, I would immediately know what all of these different things were, but I'm not. So actually, let's zoom in a little bit closer on the actual locations of today's events. Let's just look at the 1 mile region around there. Okay, let's see, I think maximum zoom level, oh, that's a cruddy zoom level. Let's try zoom level 14. I don't know if there's a zoom level 15. Let's try it. It's taking a long time, that's a good sign. Well, I wonder what that is. I'm just curious whether there is a zoom level 16 here. Probably not. Maybe there is. Very long time here. Okay. Wow. Okay. So that's where we get to see each individual tree and so on. Yeah, hard to know. I mean, this is obviously something. Generally, if it's got straight segments, it's probably of human origin. Yeah, well, I'm not sure what else we're going to be able to conclude here. I don't think this is, arguably, this is not my job, fortunately. Yeah. And so a lot of the stuff I've been doing here, this geoimage stuff, actually, I always live a little bit in the future. So this is using, for those who are serious aficionados of Wolfram language, this is using capabilities. Let's see, actually, geoimage, I'm trying to even remember. I am so, I so much live in the future, I never even remember when things, oh yes, that's 11.2, right. Which is, for most people, not quite yet out, but will be real soon. And then you too will be able to do all of this stuff. Most of the things I've been showing, though, are available on 11.1. Certainly, all of the earthquake data and so on is available. This is showing, yeah, it's so that's all available there. So more to explore. I think it would be, as I say, I would fully expect that there is some nice, I mean, I'm sure if we take an image like this, we could surely find, we could surely write something which would do the image processing. I mean, I'm sure if we simply edge detected this image here on line 59, that's probably not going to be very instructive. No, big mess. But I suspect if we do some slightly more elaborate edge detection, that we will be able to start seeing something interesting. I mean, if I don't know what would happen if we did that. Yeah, okay, so we're starting to see that structure there with that kind of edge detection. Probably if we were to do, let's take a look here. I don't know what happens if we go up to a larger pixel range. Okay, that's interesting. So we're starting to see, and if we now start to detect lines in this picture, we can probably start to write something which will automatically detect pieces here. For what it's worth. I'm also curious whether if we just look at, okay, now I'm just one more curiosity question. If we look at, this notebook is getting very big here. Let's see. I'm just going to, let's start a new notebook in for a second here. One last thing, he says, famous last words, but let's try one last thing. Let us just say random entity tunnel. Let's just pick 10 random tunnels. And this is going to be, okay, no idea what any of these tunnels are. But if we just, I'm just curious what happens if we just say geoimage for each of those tunnels, let's say a geodisk 1 mile around each of those tunnels. Let's just take the first 5 of these. I'm just wondering whether we see anything, whether it's sort of obvious what's happening. Oh, well, that's disappointing. So some of these, okay, so some of these we don't have location information. I wonder what information we do have about these tunnels. That's kind of weird. Let's go ahead and then let's just take random entity. Let's take 30 random tunnels and let's say select those. Well, let's just get the locations of all of those. So let's say positions. All right, let's delete all the ones that are missing. And then let's go ahead and do my same computation. I'm now just curious what it looks like, what the environment of a tunnel looks like, and whether it's obvious what the end of it, where the ends of it are. So now I'm just going to do geoimages, 1 mile radius around each of those tunnels. See how long it takes to compute this. It's going to have to pull in all the data for all these places. How many of them are there? And I'm not sure where. Okay. Oh, I see. Well, so a bunch of these are very, some of them are rural, some of them are not rural. I wonder whether that's an obvious tunnel because you've got a road that sort of leads to nowhere. Let's take a look here. Very unclear. Very, very unclear. I mean, I'm kind of wondering whether there's a scheme for detecting. Yeah, I'm kind of guessing that might be the thing here, kind of a road that leads nowhere. I'm kind of wondering whether there's a good image processing or machine learning way of, okay, who knows what there is there. In any case, that's, okay, I think we should wrap up here. Well, that was my afternoon, few moments of programming, just exploring some, doing some geocomputation with Wolfram language. So, thanks for watching.